Good afternoon, everybody. Hello and welcome. Very happy to be here with you guys today. My name is Vivek Vadavatit. I'm a business development manager with the Container Services team. And today I'll be speaking about operational excellence with containerized workloads using AWS Fargate. This year I've spent a lot of time speaking with a lot of customers about their experience with AWS Fargate. And as part of today's presentation, I'm going to share some of the best practices and lessons learned from those customer conversations so you can take advantage of them. And as part of that, I'll also share some customer stories and use cases so you can understand how other customers have taken this journey. And I'll also then pass it off to Shimon Toltz, who's the CTO and founder of Datree. And he'll be sharing the Datree experience with AWS Fargate, and then follow that up with a demo. So let's get started. Let me just level set for anybody who's relatively new to Fargate on what Fargate is. So Fargate is a managed container orchestration service. It's today built upon Amazon ECS. So you get the benefits of the global scale, the global availability of Amazon ECS, but you get a serverless experience in Fargate. You don't have to manage the underlying instances. You're basically looking at containers, specifying the resources that you need, and you're deploying them. The service can scale up and down based on your needs, and you'd be specifying the service scaling parameters, and it has a pay-as-you-go model. In addition to that, Fargate takes advantage of native AWS integration. And what that means is it's actually taking advantage of capabilities like native VPC integration, IAM permissions at the task level. So a task, just to level set for anyone who may be new to AWS Fargate or Amazon ECS, is a logical construct of one or more containers up to 10 containers. So you'd be deploying a task, and with Fargate, you'd be able to get native IAM control and permissions at the task level. In addition to that, integration with other parts of the ecosystem, like monitoring and logging from a CloudWatch perspective, and other parts of the AWS ecosystem. So while Amazon ECS provides a managed control plane experience, and from control plane perspective, I'm talking about how the orchestration is done, the scheduling, the task placement across your EC2 instances, what actually happens from a Fargate perspective is you no longer have to manage the OS, the Docker runtime, the ECS agent. This basically gets taken care of by Fargate. Now, we've had a lot of momentum behind the adoption of Fargate. We've had customers from every market segment take advantage of Fargate. You've had customers from media, manufacturing, electronics, startups, and enterprises all alike take advantage of Fargate. So we've had customers like Turner and Honda and Samsung and CBS and KPMG take advantage of Fargate. And they've had very successful deployments of this. So let me get into some of the aspects of Fargate. And one of the first questions I get about Fargate is, can I use Fargate in the regions I care about? So these are the currently available global regions that you can actually take advantage of Fargate. And this is available in the Americas, Europe, Middle East, Africa, and Asia Pacific. Now, let's get into some of the operational aspects of AWS Fargate. AWS Fargate starts off with a very strong operational foundation. It's actually built on the EC2 and EBS compute SLA. So our commitment is to provide 4 nines of availability. So that's a really good starting point to start building your applications. In addition to that, as with all of AWS, you get to take advantage of the multi-availability zone capabilities that are available with every region. Now, I only call this out in this presentation because with Fargate, things are a little subtle in that you have to explicitly, when you're specifying your availability zones, you're actually doing so implicitly when you're specifying the subnets that you're going to use. So the subnets map to the availability zone. So just be aware of that. And as with general deployments about availability zones, you should deploy them across as many availability zones as you can. And this is not just from an availability perspective, but also from a capacity perspective. Now, one of the features that was released earlier this year that a lot of customers really haven't taken advantage of is container health checks. So you're now able to get the capabilities around Docker container health checks in addition to load balancer health checks. So where load balancer health checks would provide HTTP and TCP level health checks, you'd be able to define custom health checks at a Docker container level and be able to specify parameters around how many times you want that to check, redeploy the service if it's if you redeploy the task if it's unhealthy, and be able to check the status of this either in the console or through the described tasks API and check the health status of that. Now, one aspect of a strong operational foundation is security. And this is really an area that customers love about Fargate. So let me dig into this a little bit. And one reason for this is just the security structure helps customers adopt container technology and not have to worry as much about the rigors of going through internal approvals from their information security teams. So let's start with the AWS shared security responsibility model. So with Fargate, AWS is now taking care of the operating system, the Docker runtime, the infrastructure, and the scaling and the capacity associated with it, in addition to what you would get with ECS in terms of scheduling and control plane management. You as a customer would be responsible for your container images, configuring your Docker containers, and also identity and access management, as well as network configuration. Now, this is a really good time to get into what the Fargate platform version is. Some of you may already be using this, but I want to take it into just highlight some subtleties. So with Fargate, you're getting a known quantity in the Fargate platform version. So at GA released 1.0, we've subsequently released 2 additional enhancements. And this is one way where we are able to release new capabilities. So you can see with 1.1, we added capabilities for the ECS service discovery, Docker health checks in containers, and other capabilities. And then we additionally added other features subsequently thereafter. Now, this is a known quantity that you can qualify your software against while not having to worry about the underlying infrastructure. So things like the OS, the Docker runtime, ECS agent, you don't need to worry about what works with what, how to deploy it. It just gets taken care of you from a platform version, but you have a known quantity. Now, if there is a security vulnerability, AWS would patch the Fargate platform version for you, and all of the things that are underneath it, the OS, the runtime, those would be taken care of by AWS as well. So some of the security benefits that you actually get with Fargate are, as I mentioned, AWS would patch the Docker runtime and the operating system. You wouldn't have direct access to the infrastructure, so there's no SSH, and there's no Docker exec in. So this helps reduce the attack surface area, and it's actually reinforcing good and best practices around making the changes through a proper CI/CD pipeline and driving best practices around DevOps and CI/CD. In addition to that, there's no privileged access. So that means that you have much less of an attack surface area, and this is also reinforcing best practices. One aspect that's actually less understood is what is the isolation boundary when you have a serverless model and you're running containers. So with a task, that is the isolation boundary in Fargate. So you don't share a kernel, you don't share CPU resources, you don't share memory resources or ENIs with another task. The task is the isolation boundary. So that also means since every task gets its own ENI and you're running in AWS VPC mode, you're getting all of the benefits from a VPC perspective. All your application traffic for your task runs through the ENI. You get to take advantage of security constructs at a VPC level, like security groups and network ACLs. You also get the benefits of using VPC flow logs to monitor your network traffic to see are there security issues that you should be aware of from a network perspective. From a registry perspective, when we launched AWS Fargate, we supported Amazon Elastic Container Registry, which is our registry platform that was created in 2015. It's highly scalable, globally available, encrypted, and also supports lifecycle policy management. Customers may choose to run public repositories as well, but very recently, in September, we announced support for third-party private repositories. So you would basically store your credentials in AWS Secrets Manager. You would then specify that in your container definition and then be able to look that up and authenticate against that. Now, any conversation about security is incomplete without compliance. So Fargate, as ECS, also supports all of the ISO certifications, PCI compliance, it's HIPAA eligible, and it supports SOC 1, 2, 3. So this additionally becomes a really strong starting point if you're running in a regulated market or you need to be able to report to your auditors that in addition to being serverless, it also meets these compliance requirements, and it takes some of that burden off of your hands. Now, once you have a strong security posture like that, one question that comes up is, OK, this is a little bit of a change of procedures for me. How am I going to now observe my applications and my containers? So let's get into that a little bit. So out of the box, CloudWatch events you can actually make that available in terms of task state changes, so you can actually monitor that there. And in addition to that, there's nothing to configure as far as service utilization for CPU and memory. So you can actually go to CloudWatch metrics and be able to view that. There's no configuration that you need to do there. In addition, you can take advantage of logging from an AWS logs perspective, which is the CloudWatch logs. And you basically just create a log group, configure your log group, and then make sure you add the task execution permission, and you're able to now view your logs through CloudWatch logs. One important capability that some of you may be aware of is task metadata. I'd like to dig in a little bit as to some capabilities of this that are really important. First of all, you can use the task metadata to query environmental and runtime information about your tasks. There are other ways to take advantage of this without actually having to do anything. You could use tools like Datadog, which has excellent integration with this, so you can actually see vCPU and memory utilization at a task level. In addition to that, if you are looking to troubleshoot or understand your task launch times or what contribution your image pull times may have to your overall task launch times, one helpful way to debug this is to use the task metadata capabilities to look at when your tasks were created and when into pending state, when the Docker image pull was started, when it stopped, so you actually understand how long is this actually taking. Is this a function of my container image size? Is there a network issue? Is there something else I should be looking into? And then you can also see when the task was started and when it's a running state. Now, application tracing is an important part as your application development processes mature. And we do have support for this through AWS X-Ray. You can actually take advantage of this. At the bottom, I've included a link. But essentially, by running this as a sidecar, you're able to actually make use of X-Ray and start troubleshooting your applications ahead of time and understand and prevent problems before they become bigger problems. Now, Fargate is not going to be, container conversations are not going to be complete without a CI/CD piece. So I want to touch on this a little bit. So we do have a reference architecture that you can actually use for Fargate for as far as CI/CD. And you can actually use the AWS developer tools, whether it be code commit, code build, CloudFormation for deployments, and code pipeline to orchestrate the whole thing. Or you can use open source tools like GitHub and Jenkins. For those who are also following Spinnaker, we are actually actively working on that. That is a work in progress. And you can follow that on the Spinnaker GitHub as well as the Spinnaker documentation. Now, one announcement that was made yesterday that is really cool is as far as ECS as well as Fargate now supports native blue-green support because of code deploy integration. So you can actually do blue-green deployments with code deploy. Now, another aspect of being able to run strong operations is especially if you're a central IT organization or you're trying to attribute cost and understand chargeback, is the support for tagging. While you've had it in EC2, you haven't necessarily had it with ECS and Fargate. You now have that as a native capability. You can actually opt into this with a new ARN. And once you've done that, you can actually make use of understanding. So what the ARN does is basically adds cluster information into your tasks. So you can actually understand what cluster it's part of. And if you're part of a service, it'll also add the service piece as well. So you can now actually go into your cost and usage report data and understand how is my cost allocated associated with this stuff? And you can also use Cost Explorer. And there's a detailed blog about this, as well as documentation that gives you screenshots and dig into how you can actually attribute this. And this will vary by customer based on how they do cost allocation internally, whether it be by services, applications, line of businesses. So it does require some focus on that. Now let me get into some customer experiences. There are 3 scenarios that I'm going to outline. The first is an enterprise-wide migration from a customer that you probably have all heard of, Turner. They actually presented here at reInvent. I think their presentations were on Monday and Tuesday. So you can probably, if you haven't been to that one, you can actually catch the replay on YouTube when it's posted. So they're obviously the parent company of companies like the Cartoon Network, TNT, TBS. And they had actually had 5,000 container deployment with thousands of services in an existing environment where they were actually managing a container orchestration platform for both the control plane and their worker nodes. And they looked at this over time, and they understood that there was a lot of complexity associated with this. There was a lot of undifferentiated heavy lifting that they were doing in terms of managing the infrastructure, managing the life cycle of all of this, and building essentially a platform on top of that to enable their developers and their different lines of business or their brands. So they looked at their options earlier this year, and they decided to go with AWS Fargate. And they did so because this would help them offload a lot of responsibilities, both from a security capability perspective, from an operational perspective, from a provisioning, and not having to do 2-factor scaling, for example, and leverage Fargate and just worry about their containers. They were able to use things like the Fargate CLI to really help the developers migrate their workloads over and be able to support deployments. And then from an infrastructure as a code perspective, they were actually leveraging Terraform. And this really helped them drive a lot of automation, drive a lot of consistency, and help adopt new capabilities much more quickly. And from a cost savings perspective, they were actually able to leverage a lot of efficiencies here from an operational perspective, as well as turn off tasks when they just weren't using them. And a lot of this stuff is now available on Turner's GitLab. So you can actually go to Turner Labs and look at their Terraform scripts, as well as their Fargate CLI fork that you can actually contribute or consume. Now, another customer that we're looking at here is an enterprise customer that's trying to launch a new idea and go quickly and go global. And this is Corteva AgriScience. They're a division, they're the agricultural division of Dow DuPont. And they do a lot of research globally on how to improve agricultural productivity. So their line of business came to them with an idea. We have a new ML algorithm that we want to use. And how do we get this out quickly and globally so we can actually get away from a lot of the manual and tedious work that we have to do? So they were actually able to look at different options, and they looked at how do we get this out quickly. So they leveraged Fargate. They used CI/CD tools from the AWS developer tools like Code Commit, Code Build, Code Pipeline, and then they deployed using CloudFormation. And they were actually able to stand this up, prove it out very quickly, and then deploy it globally. So they were actually able to get this done fairly quickly and able to get a much lower cost on doing this. They were able to automate a lot of capabilities and improve the developer experience as well. The last scenario I'll talk about is a startup. Aptiv is actually, some of you may be using Aptiv. It's basically a leading provider of wellness and fitness content. And they actually have an app that's out there that provides you with professional trainers that are actually able to provide content to you. You can pair that up with music, and you can actually leverage, work out as you need. Some exercise places, fitness centers actually make use of this for their programs, and they're actually able to do this. Now, when Aptiv started their journey to Fargate, what they looked at was they had a cost structure that they had with their existing environment. They also looked at a monolithic application. So they wanted to see how they can move that over, break it up into microservices, and not have so much of a cost structure. So they actually moved over their monolith. They were able to strip it down into smaller microservices, and then also their APIs. So by doing this, they actually were able to leverage Fargate and CloudFormation to drive better behavior internally as far as automation through CI and making changes in that form, and then they were able to actually get significant efficiencies in terms of cost savings, which they actually measure in the number of Kias that you can actually buy, Kias as in the car. So that's how they, for a startup, that's actually the metric they're actually using. So it's quite significant. So I hope with this you've understood that there are a lot of benefits that come with AWS Fargate. There are some capabilities that are available with Fargate that help you reduce your operational burden. Sometimes I get asked, where are the tips and tricks? And this is kind of the point, is you don't necessarily need a lot of these tips and tricks. You're actually building your workloads at a container level, and that's your focus, and that's where it should be. And you're getting the efficiencies because AWS is taking a lot of the burden away from you. So I'd like to pass on the presentation to Shimon Toltz, who's the CTO and founder of Datree, and he'll share his experience with AWS Fargate and then conclude with a demo.
Thank you, Vivek. Hi, everyone. Nice to meet you. My name is Shimon Toltz. So today I'm going to talk to you about our journey into Fargate and how we built our company completely serverless, using mostly Fargate and a little bit of Lambda. But in order to start, I'll tell you a little bit about myself. So I'm 30 years old. I'm one of the AWS community heroes. And this is me in a very, very happy day 8 years ago when I got a server into my lab, and I was very, very happy. Who here still has physical servers? OK, OK, you're in the right way. So I'll ask you another question. Who here has EC2 instances? OK, so that's our EC2 console. We have 0 EC2 instances running in our company, and I'm very, very happy. And I'm going to tell you a little bit more about how we did that and how we run our company. And then I'm going to show you a live demo, and we'll actually take a Node.js service and add an endpoint to it and deploy it into production. And then you can see, I'll show you the CI/CD pipeline and everything we do along the way. Hopefully, the demo gods will stick with us. So first, I'll tell you a little bit about Datree and what we do in order for you to understand how we apply the technology. So Datree is a GitOps policy engine. So for every change that a developer makes, it's being checked according to our best policies and best practices and policies engine. So think of it as an application on top of GitHub. And every time you open a pull request, it checks if you're actually working according to your best practices. So the way we see the world today of development, and it's related to this talk and to Datree, is that the world has changed. And everything is going very, very fast from development into production. And Git is actually the single source of truth that connects everything. And nowadays, companies, including my company, I open a pull request, I merge it, and it goes into production. And there is more code than ever. Everything is becoming codified. Everything is becoming, I call it YAMLified, because you don't go to a dashboard anymore in order to configure something. You just write a YAML code or YAML definition file, and then you put it in your repository, and then you push it into production. So the way our platform works is that our customers install our GitHub application. Then we scan the code of the organization, and we build a catalog. And this catalog has all of the components, all of the people, and you can see actually the view of your entire dev stack. And you can ask simple questions of like, who is using what and where? Where do I have the AWS SDK, and which versions am I using in different services? And then on top of that, we're enabling smart policies. So actually, Fargate is powering this part. Every time a customer of ours opens a pull request, we're scanning the code using Fargate. So the way it works from our side is that every time we want to actually deploy something to production, there is no procedure. There is no someone you need to talk to. You just create a branch. You make your commits. Then you open a pull request. Your peers are helping you. You have automated tests, automated scans, We have our Datree policies that help us build and make sure that we made the correct things, like not committed secrets into code. Make sure that, for example, we use the new ECS tagging feature in order to know cost and to tag our resources. Make sure that we have a Jira ticket related to this pull request, so we will know logically what we worked for. And then if all the checks pass, or we make fixes along the way, then we submit our fixes, and then we are able to merge our code into production. And this is how we deploy code into production. So a little bit about the philosophy of what brought us to using Fargate and running a serverless company. So we prefer buy versus build. Our business is to help our companies implement their internal best practices in order to prevent production outages. Our customers are always asking us for more and more features in order to help them codify their policies. We have no business in running EC2 instances, fixing them, deploying them, babysitting them. It just has nothing to do with our company. So we have no ops. The developers are the kings. And we're using any service we can get as long as it's cost effective and it makes sense to our business. So why Fargate? At the beginning, before Fargate existed, we actually used to run on EC2, ECS EC2. And it was nice. It was better than actually running it on barely EC2. But it was still a hassle. And I'll go through the things that actually made the difference for us and why we chose to move to Fargate. Now, I'm one of the community leaders in Israel, and we have a meetup group of more than 6,000 people. And people often come and ask me, how come Fargate is so expensive? If you look at the EC2 instances, the difference is very big. And I tell them, it's different. You can't compare it. It's not apples to apples. There are so many things that Fargate does and that you have to do if you're running on EC2. It's about system administration. It's about security and compliance. It's about scaling, not being over-provisioned. So how do you quantify the amount of money that it costs you? It's hard. And this is why people are having a hard time doing that. And I can understand. But I can tell you my point of view. So the first thing is that we no longer have to configure AMIs. We don't have any AMIs. In my previous job, we had a bakery with Packer, and we used to build them and babysit them, and someone wants Ubuntu, and another one wants a CentOS, and then you constantly have to keep up refreshing your AMIs and configuring them. We don't do that anymore. Monitoring and logging is just built in. It is automatically, it's a checkbox, and all of your logs are going into a CloudWatch. We use Datadog on top of that because, you know, CloudWatch is very good, but sometimes it needs some help. So we leverage that with Datadog logs. And we can have all of our monitoring and logging just built in, so we don't need to have some Elasticsearch cluster and send everything there or do custom things. The next thing is that we no longer have to deal with the operation system management. We only look at the container level. Now, of course, a container is also Linux, and you can run Alpine, you can run Ubuntu, you can run different types of containers. But we no longer care about the underlying EC2 infrastructure and the operating system. So we no longer do Linux patching. We no longer need to update our Docker daemon. I don't care. We don't need to keep track of our ECS agent version, and we don't need to have downtimes in order to update it, because Fargate does it for us. So actually, I don't know which kind of Linux my container is running on. I have no idea which AMI they use. I don't know which Docker version, and I don't really care, because our atomic unit is a container. We ship it, and it runs, and this is great. Another thing that we were having trouble with, and we no longer have to deal with, is scaling. Because back at the time when we were running ECS on EC2, we actually had to have several auto-scaling groups, and we had to have the services tasks in Fargate, and then you need to have an alignment between your EC2 auto-scaling group and the scaling of your containers. And then you need to bin pack them because you want to run cost effectively, right? So you're starting to do like sizing optimization. And again, my customers want visibility. They want governance over their development cycle. They want us to help them build policies. They don't care about my bin packing, and I don't care about it either. So there is no need for me to do that. And the most important thing for us is compliance and security, because at our heart, our core is scanning our customers' source code. So we are compliant from day one. We're running on Fargate, and we get SOC 2 and HIPAA and PCI DSS, and Vivek talked about the gazillion different certifications that are out there. I'm glad that I didn't have to do them in that matter. And it just comes as security out of the box. So when I talk to customers, when CISOs ask me about the solution, tell them it's taken care by Amazon. So it's great. So before I jump into the demo and show you how we actually deploy into production, I'll tell you about how our environment looks like. So we have two clusters, two ECS clusters. One of them is staging, the other one is production. And we're mainly a Node.js shop. And we have a microservice template. And our CI, and I will show you in the demo, determines the cluster that it has to deploy to by the branch of the code. So if it's master, then it goes to the latest one, to production. And if it's staging, it goes to staging. And we use ECR as our repository for containers, which works really great. And we use ALBs. We have internal ALBs and external ALBs. So services who only interoperate and talk to each other internally, they just use the internal ALB. And services that get traffic from outside, they use the ALB. And also, we read from queues. We talk to other AWS services. But I wanted to focus on just the containers part here. So what I'm going to take you through now is 8 steps of how we can actually deploy a change into production. And it looks like many, many steps. And lots of things are happening. But it's very, very fast. And it's very, very easy. So the first thing that happens is that we will submit our code changes. And then we will open a pull request. Then this pull request will trigger a Travis CI build. And during this build, I will show you our centralized CI/CD script. We use one centralized script for all of our microservices. Because we had a problem. As we were gaining more and more microservices, we needed a centralized solution to have our deployment script across all of the microservices. So we use S3, and we run it across all of our microservices. And we determine which cluster should we deploy to. Then we create a new task definition revision. So it will pull the new container that we pushed into ECR. Then we update the service with the new task definition. At this moment, the service starts to register our new tasks into our ALB and initiates a draining process. Now, this is very important. Many people in the community come and say, Shimon, why does my task take so long to go live? And I tell them, it's not because of Fargate. Fargate is very, very fast. The default drain time for an ALB is 5 minutes. So no matter how fast Fargate does that, your default ALB is configured to drain connections for 5 minutes. So you can change that. In my demo, I changed that to 30 seconds. And it can help you go live faster if that's your use case. So after the task is registered, we destroy the old task, and we clean up the old task definitions. So now let's try to move to our demo. Let's hope that the demo gods are with us. We sacrificed all our EC2 instances for that. OK, so I have here a very, very simple Node.js application. I chose a very simple application just to show you the whole deployment process. Of course, we have complicated microservices that do lots of things. But in this case, there's just a Travis file. We use Travis in order to do our build, and I'll show it to you now. All it does is basically define that it's a Docker, the Node.js version. It installs the AWS CLI, installs and tests our code, and then uses our centralized CI/CD deployment script, which I'll go into details about. We have our Docker file, which is also very, very simple. It's just Node.js. It's taking the code, installing the dependencies, exposing port 8000, and defines a health check, which is very, very simple. And we have our code. And in this code, we're running a Koa web server. It's like Express, only another flavor. So let's add a new endpoint. So I'm going to add an endpoint called Fargate. And this endpoint is going to have a link to a blog post that I wrote about how we migrated into Fargate. OK? So let's create a branch. OK. OK, so I'm adding the Fargate endpoint. And now let's create the branch. And let's open a pull request. Very simple. It's a very classic use case. So if we go into GitHub, we can see that I'm adding the pull request now, opening it up, and then we instantly have all of our checks running. And as you can see, we have different checks automatically triggered upon all of our repositories. So this is actually an open source repository called Datree reInvent 2018. So I can see here that I can't merge my pull request because there is some problem with my policy. Let's see. OK, so I can see that we have a policy that we should use Node.js 10 because that's the new LTS version of Node.js. And our engine detected that. So I can quickly go and fix that. So I can just choose Node 10 and update Node to version 10. And now this way I can align my organization to move and work with the new version. So let's push our fixed changes. OK, so now as you can see, all of my tests are passing because we are aligned to our policy. And we can go ahead and merge our pull request. And now that it's merged, it's going to trigger the build via Travis CI. Now I'm going to show you all the different tools that we use in order to build the container and show you the endpoint. So actually, our service is reInvent. And you can actually access it, .datree.io, reInvent. And we added our endpoint, and we will actually deploy it into production. So now it started the build process. So now I'll show you our environment. So this is the ECS console that has our task. We can see that we have a task definition, and the revision number is number 9. This is a repeat, so I already did one session. So we have some revisions. And we can see all of the different events that happened. And we can have logging built in inside of that. I think maybe that's the internet. We have our ALB that listens to our traffic. And we have our ALB target group, which will see the different tasks registered onto in a moment. So while it is building, I'll show you a very cool CLI tool, because GUI is nice, but CLI is always better. So this is a tool Fargate CLI that allows you to actually query. It's an open source written in Go that allows you to actually query your cluster. So if I want to get a definition about my service, I can just run the command. And I can see in my terminal here that we have a service named reinvent, the amount of containers that we have. We can see all of the information about that service. In addition, we can also do that for our load balancer. And here we'll see information about our load balancer. So it's really, really great for CLI usage and not just GUI. So now I'll go deeper into our deployment script and how we managed all of the different microservices. So I touched upon the fact that we have a centralized build script for all of our microservices. So another thing that many people ask me is that, Shimon, how do you manage secrets across many different microservices? That is a very, very common question. So the way we do it is that we use IAM encryption keys. And for every service, we have an encryption key dedicated to that service. And then we use the EC2 parameter store in order to store a JSON configuration for this service that is encrypted with the key of that service. So then when the service goes up, it applicatively goes and using its IAM role, it gets the key, it goes to the parameter store, gets its configuration, injects the configuration, and starts running. So no secrets in code, don't do that. Many companies got wiped by that. We even have a policy for that, and all of our customers use that. I don't even have one customer that don't use it, because that's the most horrible thing that can happen to you. OK, so now let's take a look at our build. I think it's still building. So here, it's pushing our container. And it actually, what happened is that we built the new layers. And I'll try to zoom in and also show you it better. So it actually registered a new task. And it updated the image. And it created a new task definition revision. You see revision number 10. And now it updated the service. And if we take a look at our service at ECS, we should see that we have two running tasks now, revision number 9 and revision number 10. And now if we take a look at our load balancer, we can see that we have two healthy targets now. And shortly, it should start draining one of them in order to flip the switch for the new version. And again, if it's not healthy, if it does not work, then it will keep the old version and it won't deploy a failure. So as you can see, it started draining. And the draining process will take 30 seconds. And if we look here, this is our deregistration delay. That's how I call it draining, but deregistration delay. And you can specify. The default is 5 minutes. So what does our deployment script actually do? So it's a very, very simple bash script. And we thought about doing it with other stuff, but we ended up just running a bash script. And we use Travis CI, so we determine the branch. So if it's a master, we go to production. If it's staging, we go to staging. And if it's not one of them, we're just building the tag and pushing it into ECR. Then we're doing the Docker build, Docker tag, Docker push in order to push it to the registry. And then we're actually using ECS deploy. And ECS deploy is a very neat open source, also bash script. And it's actually a script that uses the task definition and service entries in Amazon ECS. And it allows you to do a blue-green deployment. And it actually does all the magic for us. So you just tell it, I want to update this service with this container, with this new definition, and it just goes there and does it for us. So as you can see here, we're just executing it with different parameters. And we're giving it a timeout. We're defining the amount of definitions to keep all the old task definitions are getting deleted. We specify the service name, the image, and that way it is being deployed. So now, if we actually go to Fargate, hopefully we have our blog post. So it's very long. You can just go to the AWS Fargate page, and we're a case study there. So hopefully this helps demonstrate how easy it is to actually deploy something into Fargate. I like it because it uses Docker, and the underlying infrastructure is baselined. We also have stuff that uses serverless framework, which is also great. But for us, we like running with containers, and it really, really helped us. So now any developer that wants to actually go and deploy into production, it just takes the template, makes a service, and goes to production. So just to finish up, I'll talk a little bit about the challenges that you might face if you're going to use Fargate. So the number one thing is that Fargate has a limit of 10 gigabytes disk space. And for some workloads, it might be problematic. I can understand that. I hope that they're working on it. Currently, what you see is what you get. And I think that this is the reason is because you cannot change the instance type that you get. So that's another limitation. So let's say you have a GPU-optimized instance, a workload that needs a GPU, or you want a CPU-optimized one, or a memory-optimized one, or I/O-optimized one. You can't choose. You don't even know which instance you're running on. For our use case, it's great. For your use case, you should consider, I don't know, it depends on what you're running. Another thing is that you can't attach an EBS volume or use EFS. That's also a limitation. You can use S3 and stuff like that applicatively from your application, but in terms of the container, you can't do that. Another thing is that in terms of pricing, the direct pricing, so spot model is not supported. So you might use other solutions like Spotinst, for example. They provide some sort of solution with containers that tries to do something similar to Fargate on spot instances. But currently, you can't run spot. So I understand. I have people who come and tell me, listen, Shimon, we run like 100 instances, 8 Excel with spot instances. If we move to Fargate now, it's just going to... I understand. For us, it works. It's really well. And another thing is that there is no reserved instances, you would call it, reserved containers. And I talked a little bit to the team about that, and they said that they don't just want to copy-paste and lift and shift the RI model that we currently have with EC2 instances into Fargate. They want to think of a model that is more appropriate to this container-first world. So I hope that we will get an option, and once there is an option to buy reserved capacity, I will be the first one that buys that. So the final thing is, we're a proud open case study of Fargate. Fargate helped us win customers because it's very, very secure. It runs on Amazon's environment. We really love it. We're an open case study. If you want to go and read a blog post that I wrote step by step of how we migrated from EC2 to Fargate, this is the blog post. And with that, I want to tell you thank you. And me and Vivek, we will be here to answer any questions you might have. Thank you very much for coming.